should do. We'll let the cornflakes spin.
So gross. I hope you're not going to eat that cereal at your house.
Oh gosh, I hate that cereal. The only reason I got that cereal was because it was 100% of your daily needs of iron. And so I figured at that rate that I'd be able to actually get that experiment to work. I was like, because you know, even though I had that... that'll do. It's not great, but it'll do. All right. So even though it was 100% of your daily needs, you know, it only had like that much iron. You know, there was not a ton of iron there.
I'm going to get a cereal with iron free.
I bet you can't find a cereal that is iron free.
Yes.
So that is one of the things that you can do to separate a mixture. You can use the property of the mixtures, one of those properties being iron is magnetic. Now, can you use a magnet to get out things that have non-magnetic properties? No. It is really, you know, you have to use the properties. Here is my face scrub with the bits of apricot in it. Y'all take a look at this? Okay.
Is that a mixture?
It is. Can you actually see the pieces? If you can see pieces, it's a mixture. Can you see? You can't see pieces in all mixtures, but there's no way you're going to see pieces of a compound. Okay? Your eyes see a certain size. If the pieces are too small for you to see, then it's all going to look like one thing, even if there's more than one thing there. Okay? But if you can actually see pieces, it is absolutely a mixture. Does that make sense? Yeah, you should write this stuff down. So I'm taking my little face scrub here, and I am stirring it up with a little extra water, trying to get that mixture a little bit more... We'll put it in there.
Oh, that just looks lovely.
Lovely, but it feels great on your face. Totally does. does.
Oh, geez, this should be good.
Wait, Miss Martin, is there something after or?
Yep.
Is it a fan?
You can use density or a centrifuge, I think is how that's set up.
Is it trying to mix it?
It is not trying to mix it, it's trying to separate it. That tool is called a centrifuge.
Oh, is that what they use to separate blood?
It is. This is the tool that they use to separate blood.
So it's not fucking.
Centrifuges work best on suspensions. Okay? Especially suspensions where the ingredients have different densities. Now, sometimes you can use density and it's super easy. Think about, what if I have a mixture of foam and sand and they're all the same size pieces? How are you going to separate those? Foam and sand, how would you separate them? Yeah. What do you think? A centrifuge wouldn't work if it was just the foam and the sand. You might need to add something else to get the centrifuge to work. But you might not even need the centrifuge if you pay attention to the densities of the substances. Yeah.
Pour it in water?
Yeah, if you pour in water, that would work. Because sand has a density of more than water, and foam has a density of less than water. So then the foam would float and the sand would sink, and then you just scoop the foam off the top.
Why was that going when we came in the classroom?
Because I wanted to get a good result. Oh, this one's good. That works better for the balance. All right, so here you can see that all the little nuts of the apricot scrub all kind of ended up in one spot.
That's a lotion?
It is not a lotion. It's a scrub.
Oh, yeah. What's the difference?
What's the difference? A lotion you put on your skin and leave it. A scrub is like soap. You put it on your skin, you use it, and then you rinse it all off again.
Like,
This has bits of seeds in it. Do you really want that leaving on your skin for... No. It's the seeds are like, have you ever used a back poof?
no.
Like one of those, like a loofah? Same purpose.
I don't know.
A loofah. The purpose of a loofah is to exfoliate, which means to take the dead layer of skin off the top. Yeah.
Pink and sparkling.
Yeah. I don't use a loofah. Well, I do. But I really like this stuff too, so. See the little
Miss
seeds?
Martin, is there a reason
No.
you wore that shirt today?
It's Friday.
What about
You wear
Fridays?
that shirt every day?
I wear this shirt most Fridays.
Wait, Miss Martin, is Friday jean day for teachers?
Yeah.
Guess what? I'm gonna wear jeans every day.
Kicked out.
Friday's jean day.
Yep, Friday's casual Friday. Jeans and t-shirt. Jeans and a school-related t-shirt. So my science geek t-shirt, I'm a science teacher, so it's still kind of
Wait, every day you guys have to wear,
nicer clothes than you most of the time. This is the goal.
excuse me?
Yes.
No,
Yes,
I mean,
jeans and sweatshirt, girl.
No,
Yes, I'm supposed to wear nicer
I'm
clothes than you
saying-
most of the time.
every day you have to wear a school-related shirt.
Fridays, if I'm wearing a t-shirt, the t-shirt needs to be...
Too many rules, I couldn't keep up with that.
At least she admits it.
All right. You can also use the different boiling points of substances. You can use the different boiling points of substances to separate them as well. Remember I put salt water in this watch glass?
Is it hot?
Yeah, it's on the stove.
Wait, what did you put in there again?
Salt water.
Did it evaporate?
Yeah.
Oh.
Now it's just salt.
I'm so surprised that you guys did that.
Now I just have salt.
What temperature does water boil at?
212 degrees Fahrenheit.
212 degrees Fahrenheit. What class is this?
Science.
But you didn't listen to me. I started to say 100 degrees Celsius.
All right. Just checking. Just checking. All right. So it's 100 degrees Celsius. Now I know that you don't know the exact boiling point of salt, but what's the ballpark?
800.
800 is a decent ballpark. So what's colder, 100 or 800? 100. So I put this salt water mixture on the stove. As soon as the salt water mixture gets to 100, what happens to the water?
Evaporates.
It evaporates. Where does it go?
In the air.
In the air in the room. Does it break apart and turn into something else? No, it's still water. It's just water that's in air in the room. And the salt is still salt. The salt is still salt, but now it's on this disc instead of dissolved in the water. That is how you separate things in a solution. Is you use their different boiling points.
Does that mean it turned from a liquid to a solid?
Nope. Not really. It's not the same as a phase change. It was dissolved, and it looked like a liquid, but the pieces were so small that they didn't have a state, at least as far as I know. Okay?
Who did that?
Okay.
That wasn't me this time.
Who was it?
Okay.
All right, the parts of a different mixture don't have a set amount. There's not a set ratio. Can you get a pizza with extra pepperoni?
Yes.
Okay, it doesn't mess up the pizza to have extra of something.
Nope.
Okay? Mixtures allow the combos to be completely different. Air is a mixture. It is not even mostly oxygen. It's mostly nitrogen. So each breath you take is a mixture of nitrogen, oxygen, carbon dioxide, water, argon, and random air pollutants. Every single breath. Then your lungs kind of act like hands. Your lungs look at this mixture. They have a little tiny sample of the mixture that you just breathed in front of them, and they pick out, this is an oxygen molecule. That's an oxygen molecule. That's an oxygen molecule. And they pick out the oxygen molecules in the mixture of the air that you breathed. And they put those oxygen molecules into the blood to go be used by your body. And then it takes out of your blood the carbon dioxide that you don't need anymore and puts it back into the mixture. So if you breathe a nitrogen atom, the same atom you breathe in is the same one you breathe out. But your lungs have fished out all of the oxygen and have thrown in as the spare carbon dioxide. So even though you breathe oxygen, you're actually breathing a huge combo of stuff. And your lungs just fish out the oxygen. Does that make sense?
Yeah.
Okay. So, and the air doesn't have the same combo all the time. Sometimes there's more water than others. For example, in the summertime, you ever hear about humidity?
Yeah.
That means there's a high amount of water in the air. How many of you guys have chapped lips?
I got mine.
All right. Chapped lips happen a lot in winter because there is less humidity. You are a bit dehydrated when you have chapped lips. One of the ways that you can help that is to drink more water.
Just water, folks.
So, all right, that's what we got for today.